Hi class. We continue our study in chapter 9 talking about right triangles by moving into section 9.2. 9.2 is talking about special types of right triangles. So we have two objectives. We just want to learn the properties of what we call 45, 45, 90-degree triangles, and then finally use the properties of 30, 60, 90-degree triangles. Now these are the two special types, and the way we classify them as special types is by the measure of their interior angles. Okay, so the first one is the theorem related to 45, 45, 90-degree triangles. So in a 45, 45, 90-degree triangle, both legs are congruent. So the two legs here of the triangle are of the same length, right? And the hypotenuse is just the square root of 2 times the length of a leg. So a hypotenuse is equal to the square root of 2 times the leg taken from the triangle. So the hypotenuse is equal to the square root of 2 times x, because that's what we're classifying as the length of a leg, or x times the square root of 2. All right, let's do some examples here. So let's find the value of each variable. All right, well, if you look here, you can see that it's a 45, 45, 90-degree triangle. So this is the hypotenuse of the triangle, and these here are the two legs. What we see is one of the legs is equal to 9 units. All right, so we know then that the hypotenuse h is equal to the square root of 2 times the length of the leg. Well, the hypotenuse here is the square root of 2 times 9, or just 9 square root of 2. So that's it. That's all you have to do for the hypotenuse. Now, the length of the other leg, z, well, that's 9 units since the triangle is isosceles here. So the 45, 45, 90. All right, because the theorem tells us that these two legs will be congruent. Let's do another one here. So I've got 45, 45, 90, and I want to find the value of the variables x and y. All right, well, what you can see is x here is the hypotenuse. So this gets a little weird because the length of a leg here is 2 square roots of 2. But the hypotenuse here, let's just follow the formula. The square root of 2 times the leg. Well, the leg here is 2 square roots of 2. Well, square root of 2 times square root of 2 is 2. Times this 2 gets me 4. So the hypotenuse here is 4. And the length of this leg, excuse me, is also just 2 square roots of 2 because these two legs are congruent. All right, let's do another one. Let's find the value of x here. All right, so I am giving you the hypotenuse, and I'm telling you, and I'm asking you to find the measure of this leg right here. All right, well, we're just going to follow the formula. The hypotenuse is equal to the square root of 2 times the leg. We'll plug in 6 for the hypotenuse, and the leg is still just x here. So to solve this, what you have to do is you have to divide the square root of 2 over and get this. Well, you see that none of these are the options that are there. So actually what you have to do is you have to rationalize the denominator. So you have to take the square root of 2 out of the denominator. So to do that, you multiply both the top and bottom by the square root of 2. That gets you 6 square roots of 2. Square root of 2 times square root of 2 gets me 2. Well, then the 6 and 2 simplify to just be 3. So the length of x here is just 3 square roots of 2. All right, so the correct answer here is B. All right, let's do a baseball example. So a high school softball diamond is a square. You can see over in the picture here. So the distance from base to base is 60 feet. All right. So to the nearest foot, how far does a catcher have to throw the ball from home plate right here to second base right here? Well, what you can see is because these are diamond, these are all 90-degree angles. So what happens is this diagonal cuts the angle. So 90 cut in half, this is a 45, 45, 90. So because the distance from the base along the square is the same, the distance d is the length of the hypotenuse of a 45, 45, 90-degree triangle. And the distance there that the catcher has to throw it, right, is just the length of a leg, which is 60 feet, times the square root of 2. Or roughly, they would have to throw the ball 84.8528 feet. All right, let's now talk about a 30, 60, 90 triangle. So in a 30, 60, 90 triangle, the length of the hypotenuse, now forgive this is a little bit of a typo here, is twice the length of the shorter leg. So you have your 30, 60, 90. So the shortest side will be opposite the 30-degree angle, so that'll have length x. What we're saying then is the hypotenuse is just 2 times x, or it's twice the size. in the longer leg here, all right, the length of the longer leg is a square root of 3 times the length of the shorter leg. So square root of 3 times the shorter leg right here, right? And the longer leg is opposite the 60-degree angle. So shorter side is x, longer side is x square root of 3, and hypotenuse is 2x. All right, forget this little typo here. All right, so let's do this. All right, let's find the value of d in the simplest radical form. All right, well, what you can see here is d is the shortest side here. What we're saying here is the longest side is 5. So you're given the length of the longer leg and asked to find the length of the shorter leg. So that tells us what formula to start with. So longer leg is equal to square root of 3 times the shorter leg. Well, plugging in 5 and d for the shorter leg, you get 5 is equal to d square roots of 3. So all you have to do now is divide by the square root of 3 like this. You're going to have to rationalize the denominator. So whatever the fraction or the radical is in the bottom of the fraction times by the square root of 3 over the square root of 3. Square root of 3 times square root of 3 gets me just 3. And the distance here of this is 5 square roots of 3 divided by 3. All right, let's do another one. All right, and this is a practical example. So an artisan makes pendants in the shape of an equilateral triangle. So an equilateral triangle means all the sides have the same length, okay? Or all angles are congruent, excuse me. So the height of each pendant is 18 millimeters. So you can see here, that's the height right here. What is the length S of each side of the pendant to the nearest tenth of a millimeter? So this side, and this side. Well, an equilateral triangle can be divided into two 30, 60, 90 triangles, right? So this is the 90-degree angle. Remember, all of these angles are an equilateral triangle are 60 degrees. So this cuts it. So this angle and this angle here are each 30 degrees. All right, so the hypotenuse of each 30, 60, 90 triangle is S right here. And the shorter leg is half of S. So this right here is half of S. All right, so I got the longer leg is equal to square root of 3 times the shorter leg. So 18 is the longer leg here, right? Times 1/2. This right here is 1/2 of this side because it's an equilateral triangle. So this cuts this side in half. So solving here, you get this. I would cross multiply, right? Or multiply both sides by the flip of this, right? So you get 2 times 18 divided by the square root of 3 is equal to the same thing over here. Multiply both sides by the same. But the 2's will cancel out and the radical 3's will cancel out. And you get 36 is equal to the square root of 3. All right, so S right here, the length of each side of this pendant, is roughly 20.7846 millimeters. All right, so roughly each side of the pendant is about 20.8 millimeters long.